Hi students, welcome to Max Point of View. Today we are going to solve all the theory questions from the chapter Refraction through Lens, that to part A, Lens and Refraction through Lens. Here my suggestion is, before solving the theory questions, you have to watch the concept video. Then only you will understand everything whatever we are going to do today. But without watching the concept video, if you are seeing this one, then most of the questions you will get the answer, but you will not get why it is the answer, how we got to conclude it, all those things. So that's my suggestion is, watch the concept video first, then come back to this, then definitely will understand everything. So without wasting any time, we'll start with our first question. Our first question, what is a lens? Lens is a transparent refracting medium. See, it's a transparent refracting medium. It is not reflecting, refracting medium bounded by two spherical surfaces or one spherical surface, one plane surface. That's it. This is the definition of lens. This is how you have to learn. You should not just keep on by hearting the things. See, it is the lens is a transparent refracting medium bounded by two spherical surfaces or one spherical surface and a plane surface. That's it. Our next question, which lens is converging? So we have to identify which is the converging lens. First one, equiconcave lens or equiconvex lens. We know convex lens is the converging lens, correct? So out of the, in the first question, equiconcave, it is not converging. Equiconvex lens is the converging. We can easily identify this one. See, that is why I'll tell you, watch the concept video, then you will understand all these things. Convex. Second one is a combination of both the lens. We have one lens, in one lens only we have both combination, concave and convex, convex and concave. So out of these two, concavo-convex lens or convexo-concave lens, out of these two, which is converging lens? How to identify this one? Very simple. So in these kind of situation, at the end, at the end it has to be convex. At the end it has to be convex. The second lens should be convex. See the first option, concavo-convex, which is the convex is the second option. That is the correct. Second one, convexo-concave. Here second lens, convexo-concave. Here the second one is concave. So this is the wrong option. So answer is concavo-convex lens. Why it is converging, we have learnt in the concept video. Our next question, state the condition when a lens is called an equiconvex or equiconcave. So very simple. The answer is the radii of curvature. The radii of curvature of both the surfaces should be equal. When these two are equal, then we can aramse say whether it is convex, equiconvex or equiconcave. What do you mean by that? Radii of curvature. See, if you take one lens, in one lens I can create two spheres, correct? Two spheres. So here the radii of curvature from this one to the center, from the center of the sphere to the center of the lens, again from the center of the sphere to the center of the lens. These two are radii. These two are radii. You can take this one R1 as R1, this one as R2, anything is fine. Here both the radii, this one radius and this is also radius, both the radii should be equal. So because here we have two surfaces, because of this surface, this surface we have created a circle, because of this surface we have created a circle. So radii of curvature of both the surfaces should be equal. Then we can aramse say it is equiconvex or equiconcave. Our next question, define the term focal length of a lens. That's a very simple question. This is what we have learnt in concept video. Listen, with the diagram I'll explain you. The distance, see, whenever a object is kept in front of a lens, if a ray goes in any direction, there is no need to be, it is always should be parallel to principal axis. No, in any direction it converges, correct, it converges because it is convex lens. So here whenever this ray crosses the principal axis, this point is called as focus. This point is called as focus. Now we'll talk about focal length. The distance between the optic center of the lens, to the principal focus, to the focus is also fine, to the focus, the distance between the optical center of the lens to focus is called as focal length. Our next question, what do you mean by focal plane of a lens? See, this question, this concept, focal plane, first focal, second focal, all those things are not there in the syllabus, so for now don't worry about it. Our next question, state the condition for each of the following. A lens has both its focal length equal. Okay, when a lens can have both its focal length equal, then a ray passes undeviated through a lens, through the lens. Okay, very simple. First one, when can a lens, assume this is a lens, you can take, see, there is no rule that I have to take convex lens always, you can take concave also. Okay, see here, a lens, when a lens has both the focal length, here also there will be one focus. Okay, here also both the sides we have focus. See, all these things, ray diagrams, okay, properly we are going to learn in part B. Okay, here just a simple diagram we are going to learn. So in part B we are going to learn everything, don't worry about it. So when a lens have both the focal lengths, a lens will have two focal lengths. Okay, here when the medium on either side of the lens is same, see, on this surface it is air is the medium, and this surface also, this is the second surface, right? So this surface should also have the air as a medium. When the medium is same on either side of the lens, then they will have same focal length. Second one, when a ray can pass undeviatedly after passing through a lens. That is a very simple question. If you pass any ray passing through the optic center, any ray passing through the optic center, both the lens, concave and convex, there will be no deviation. It passes like this. I'll show you one example. See, I'll show you both the lens. If a ray passing through the optic center, there will be no deviation, no refraction. So like this. Our next question, if half part of a convex lens is covered, the focal length dash change but the intensity of the image. So here we know whenever we cover half side of the lens or any part, upper part or lower part or some part of the lens, if it is covered, we know many things will not change. What are those things will not change? Focal length, the position of the image, nature of the image, size of the image, these things will never change. The only thing will change is brightness or intensity of the image, correct? That you should know. So here first, okay, in question A, first dash is about does not. Okay, and the second dash, so here it decreases. But the intensity of the image will decrease, correct? Next, a convex lens is placed in water, its focal length increases. This is what we have learned, correct? See, this is little confusing, I know. You have to watch the concept video. At the end we have given so many note points. In that, this is the question. So this is very important question because many students will get confused. Next, the focal length of thin convex lens is dash of the thick convex lens. We know the thin convex lens will have always more focal length. Thin convex lens or any lens, thin, okay, convex or concave, okay, it has more focal length. Our next question, name the two kinds of lens, draw a diagram to illustrate them. Very simple. What are the two lenses we have learned? Convex and concave. So first one, convex. the diagram. This is a very simple question, right? These kind of questions don't expect in the exam, but if the complete paper is logical, these kind of easy questions will be asked. So other one is concave lens. Done. Convex and concave lens. Our next question, state difference between a convex and concave lens in their appearance and action on the incident light. So this is very simple. See, appearance, what do you mean by appearance? Appearance, how it looks. Okay, very simple. It is thick in the middle, thick in the middle than periphery. Next, concave, it is exactly opposite. It is thin in the middle compared to than periphery. Next, so they are talking about action. What kind of action? That means whether it converges or diverges. Convex lens, it is always converging lens. Okay, it converges. Okay, you can write it as it converges the incident rays. Here this one diverges the incident ray. Then the last one, see, even though they are not asking, we'll write that one also, because this word is very much important, which we are going to learn. Convex lens has real focus. Okay, real focus. Concave as virtual focus. Why it has real and why this has virtual, all those things we have learned in concept video. Our next question, define the term principal axis of a lens. Principal axis is nothing but it is a line joining both the center of curvature of both the surfaces of a lens. Very simple. See, if you understand through the diagram, you can take any lens. Okay, so assume this is one circle and this is one, sorry, sphere. So this is the center of curvature of both the lens. The line joining center of curvatures of both the surfaces of a lens. Our next question, explain optical center of a lens with the help of proper diagram. Okay, listen, diagram or diagrams, anything is fine. Listen, what is optical center? Say first you draw a lens. So diagram can also be drawn. They are asking for the diagram also, right? So this is the optic center of a lens. Oh, it is denoted as optic center is a point on the principal axis of a lens where if a ray passes through optic center, it emerges out without deviation. This is the explanation and diagram for optic center. Our next question, a ray of light incidented at a point on the principal axis of a convex lens passes undeviated through the lens. What is the special name is given to this point on the principal axis? Okay, we have to draw the diagram. See, if it is passing undeviatedly, that means it is nothing but it is passing through optic center like this. So what is the name given for this? Optic center. Okay, CENTRE is also fine. Okay, UK English and US English. Okay, this is the diagram they are looking for. That's it. Our next question, define the term principal foci of convex lens and illustrate your answer with the aid of proper diagrams. They are especially talking about convex lens. See, what do you mean by principal foci? Principal focus we know, F, capital F. Principal foci, that means two capital F's. That means, see, whenever you take a convex lens, or they are talking about convex lens, right? You can take convex or concave, anything is fine based on the question. Now listen, so what do you mean by principal foci? This side also I have one focus and this side also I have one focus. Okay, why do we have two focus? Why? Because a ray, see, if the ray goes from here, this side, from left side, after refraction it is going to converge, correct? But there is a chance that a ray can be incidented on that angle also, on from the other side also. So the a ray can be passed on either side of the lens. That's why, hence, the convex lens has two principal foci. Our next question, define the term principal foci of concave lens and show them with the help of proper diagram. The same question, here it is concave, if the previous question was convex. Listen. Okay, assume this is the concave lens. So here, what is, this is the principal axis, optic center, here f2 and here f1. See, the here convex lens, I have taken f1 here, f2 was there, but concave it is ulta. Okay, so all these things we are going to learn in part B, don't worry about it. Here just for the sake of answering we are doing it. Now complete knowledge you are going to get it in part B only. Now listen, so what do you mean by principal foci? A ray can enter from this angle, okay, this side or this side, correct? So if it is passing from this side, this will be the focus. If it is passing from this side, it will diverge, correct? It will diverge and this will be the focus. So a ray can pass on either side of the lens, okay, hence the concave lens, has two principal foci. Our next question, out of the two lenses, one concave and the other convex, state which one will show the divergent action on a beam light. Draw a diagram to illustrate your answer. Okay, very simple. See, out of two lenses, it is diverging concave. So that is answer for first one. So answer is concave lens, and we have to show the diagram. Oh, this is principal axis. So if it is parallel, previous question only we have learnt, if it is parallel, what happens? It diverges away. After refraction it diverges away. That's it. So whenever you are drawing the ray diagrams, use scale. Okay, then only you will get full marks. Our next question, show by a diagram the refraction of two light rays incidental parallelly to the principal axis on a convex lens by treating it is a combination of glass slab and two triangular glass prism. So I know you got confused a bit, but it is very simple. This is what we have learned in concept video. So you take a convex lens. In the convex lens, see, this is the convex lens. Okay, in this convex lens, make this as two triangular prism and a glass slab. Like this you have, if you draw like this, aram se you will get it. See, two triangular prism and a glass slab. Now we have to incident two lights. Okay, two incident rays. So which has to be parallel to principal axis that they have given. This is parallel to principal axis, correct? This is principal axis, optic center. Okay, both should be parallel to principal axis. We know in convex lens, this is convex lens, right? In convex lens, what happens after refraction? It will converge. Converge means moves towards the principal axis. See, like this. This is where we are going to get the focus. Okay, so this is the diagram they were looking for. Our next question, show by a diagram that refraction of two light rays incident parallel to principal axis on a concave lens by treating it as a combination of glass slab and two triangular glass prisms. The same question, but here we have to take the convex lens. First draw the here we have to take the concave lens. So here draw the concave lens first. Once you draw it, split it. Okay, glass slab, see, triangular prism and a rectangular glass slab. Okay, the diagram is done, and this is the principal axis, this is the optic center. Next, we have to take two parallel lines. parallel to principal axis. See, all these things we have learnt in concept video. What happens if it is parallel, what if it is not parallel at the end of the video. That's why, so my suggestion is watch the concept video first, then only you can draw all these things. Again we are going to learn all these things in part B, but if you have learnt in part A only, part B would be little easy. So here, after the refraction, what happens? It diverges, correct? It diverges. So if you extend these lines back, okay, here we are going to get the image. That will be virtual image. Okay, that's it. Our next question: how does the action of convex lens differ from that of concave lens on a parallel beam of light incident on them? This is what we have learnt in the previous questions also, but here we are going to draw both the lenses at the same time, then you will understand properly. See, first I'll draw the diagram. Convex, if two rays are parallel, this is principal axis, optic center, and concave, optic center, principal axis. Okay, see, in convex lens, after, see, this is what you have to write. So in convex lens, okay, if the rays are parallel to principal axis, after, okay, refraction, it converges. That's it. Okay, here we are going to get focus. Okay, next, in concave lens, if the beam of light are parallel to principal axis, after refraction, it diverges. And we extend these 2 points. See, we are never going to get the image when it comes to concave. That is why, to get the virtual image, we have to extend those 2 lines. We'll get the image. That's it. From question number 5 to question number 13, many questions, okay, are out of the syllabus related to focal plane, first focus, second focus. All those things are not in the syllabus, and few questions we have already drawn. That's why we are going to skip from question number 5 to question number 13. This knowledge is enough. Okay, this is enough for you to score the complete marks in part A. The remaining questions are out of the syllabus, so we don't have to worry. Now we have solved all the questions which are there in the syllabus. So after this one, directly move on to part B. There we are going to learn the ray diagram. Thank you.